Welcome to another Algebra and Surds video. This one is having a look at binomial products. Okay, we're asked to expand and simplify this. We've got m plus 3 outside of m plus 6. Well, the way I'd like to do them is to split that middle term here and say I want to do m outside of m plus 6 because that m is multiplying by that other bracket. And then separately think of 3 plus 3 multiplying by m plus 6 as well. Kind of listed the m plus 6 bracket twice, and we're splitting up this first bracket and multiplying each of them through that m plus 6. So carefully we'll run through this. M times m is m squared. M times 6 is plus 6m. 3 times your m there is plus 3m, and 3 times your 6 is 18. And there's one last thing to do. Can you spot there's some like terms there, some terms with the same letter and power? We're allowed to join those two together, end up with a final answer of m squared plus 9m plus 18. So we split that term. There are other ways to do it. Some people do it using a FOIL acronym, mnemonic sort of thing, for multiplying the first ones, then the outside ones, then the inside ones, then the last ones. This is the way I do it, but we'll probably end up with the same answer if we did it. Okay, this one here, we'll do a similar thing, where we'll split this term up, multiply the 3a by this bracket here, and then multiply minus 4 by this bracket. Anytime you're multiplying with a front number that's a minus, we'll have to be pretty careful with our multiplying though. So we'd write that out separately carefully. 3a multiplied by that second bracket, and then minus 4 multiplied by that second bracket. So we've split that front term and we're multiplying each of those front terms by the second bracket really. Multiply that by that, we've got 3 times 5 is 15, and we've got an a times an a, so that'll make an a squared. When we multiply these two, we've got 3a times 2, which will make 6a. Now here's where we've got to be a little careful. Minus 4 times 5 is minus 20, and minus 4 times plus 2 is minus 8. So many students will get that wrong because somehow on that second expansion, that second multiply, students forget that it was a minus number in front there, so careful with that. Don't be one of those students that fall into that trap. We're allowed to combine or collect those like terms there. They're two terms there that have still got the same letter and power. So we'll collect them. 15a squared. Now a plus 6a minus 20. That's kind of like a number line situation. If you started off at plus 6a on the number line and went 20 jumps to the left, you'd end up in the minus section. So you get minus 14a. You might like to check that on your calculator if you're not sure of your minus and plus rules there. There's your final answer there, 15a squared minus 14a minus 8. Now this one can be done just quite simply in terms of, if that's a squared, that will equal g plus 2 multiplied by g plus 2. So there's nothing wrong with doing it that way. There is a shortcut way. Let me just expand this as if it's like that. So, I've just told you about that. We'd have that, we'd split that term there, and we'd say g outside of g plus 2. We'll get into that shortcut. There's a shortcut version that we should memorize as well, but we'll get to that in a minute. So if we expand this carefully, we'll get g times g, which is g squared, g times 2, which is 2g, plus 2 times g, which is another 2g, plus 2 times 2, which is 4. And we can collect those like terms, g squared plus 4g plus 4. So there's nothing wrong with doing that. If you remember that there's this shortcut rule that says any term plus another term, we'll call it a plus b here, if that's squared, there's a shortcut that says, okay, we square the first one, and we add it to two lots of the product of those two, so two lots of a times b for that middle term, plus the last term squared. So that's like, they call that perfect squares. It's a shortcut that we could use. Now, so if we're saying g is the first term and 2 is the second term, if we use this shortcut, that would get us the same answer as we got doing it the long method. So that first term would be g squared, and it was. This second term would be two lots of g times the second term, which is 2. That would end up getting us 4g. And squaring that last term, in this case squaring 2, would give us the 4. So you can see that that fits the pattern as well. So there's an argument that says if you know that perfect squares shortcut, that will enable you to do this question a bit quicker, and that's probably true. You might save a couple of seconds in a test if you know the shortcuts there. And some questions are actually based on knowing that shortcut for perfect squares, so it's worth memorizing if you can get around to it. This one here, we'll do it the long way as well. We've got a bracket here that's being squared, so it's really talking about h minus 4 multiplied by another h minus 4. That's how we get a square. Multiply the same thing by the same thing. And we could split that middle term, that first term there, and multiply h by that second term, and minus 4 times that second term. Then we'll talk about a shortcut version that is worth memorizing for this as well. Let's just do it the long way first. H outside of h minus 4 minus 4 outside of h minus 4. So I did that term times the bracket, and that term times by the second bracket there. So if we carefully expand that, h times h is h squared, h times minus 4 is minus 4h. We've got another minus 4h there. And minus 4 times minus 4 makes plus 16. Be careful there. That's another trap for many students. They forget somehow on that very last multiplication that it's a minus times a minus making a plus. And here we can collect some like terms. The h squared needs to go at the front. Now you've got minus 4 minus another 4. That makes minus 8h plus 16. Now I'll tell you about the shortcut here, or the system you can memorize. The first term can be called a, second term can be called b. When we square that, the shortcut or the perfect squares system really describes a situation where you've got the first term squared minus, this time, two lots of the two terms multiplied together, plus the second term squared. That last bit's always a plus. So if we had an h as our first term, it should be squared out the front, which we got. Then this middle term is based on a minus, which we got, and then a 2 times those two terms multiplied together. Those two terms multiplied together would give us 4h, and then minus 2 times that gives us a minus 8. So our answer here, doing it the long way, agrees with this over here, particularly when we say that this second term is getting squared. So 4 squared is our 16 there. So once again, it's worth memorizing that at some stage, because it can save you some time in tests if you know that, and can expand a bit more quickly than doing it the long way. Alrighty, so here we can just do it the long way. We could fit it into that other perfect squares shortcut system if you like, but you could just suggest that this is just 3k plus 4 multiplied by itself, because it's getting squared, isn't it? So we could split that up and say 3k times that bracket plus 4 times that bracket. So 3k outside of 3k plus 4 plus 4 outside of 3k plus 4. If we expand this carefully, we've got 3 times 3 is 9k squared. 3k times 4 is your 12k. 4 times 3k gives you another 12k. And 4 times 4 is 16. Got some like terms to add together there for a slightly simpler answer. 24k plus 16. Now that could work with that perfect squares shortcut if we squared that first term and make sure we're squaring the 3 as well as the k there. We'd get 3k times 3k, or 3k squared is 9k squared, plus two lots of this multiplied together will give us our 24k, plus the last term squared gives us our 16. So that we can do that with using that perfect square shortcut as well. And we've got this one here. I'll show you the long method. Why don't we do this the short method? Okay, so we've got a minus b all squared, because we have got two terms that with a minus in between are getting squared there. So this one says first term squared minus 2 lots of a lots of b plus the last term squared. So if we underneath here, I'll put this into a different color and just show you that we can fit these two terms, indicate that they're the first and the second term here, and we'll just fit these into the pattern that is produced by the rule about perfect squares. So a squared kind of represents the first term getting squared there. So we could carefully write 5m all squared, because that's our first term getting squared, and we'll simplify this a bit in a minute, minus 2 lots of our first term, which is 5m, a sort of represents our first term there, lots of the second term, which is 6, plus our second term squared, which is our 6 squared. 6 looks like a b anyway, doesn't it? Okay, now 5m squared, 5m is inside the brackets, so the 5 needs to be squared as well. You'll get 25m squared minus 2 lots of 5 is 10, lots of 6 is 60m, and 6 squared is 36. So that's our final answer there. We would have got that if we were carefully just writing out those two brackets. We could think of it as 5m minus 6 times itself, 5m minus 6. So if we expanded that carefully the long way, we would get that. But I wanted to show you one where we were following the perfect squares format there, if we knew that in our brains. So it's worth memorizing these perfect squares scenarios. You can also take a little extra time and just do it the long way if you want. If you have 5 minutes at the end of a test, you could even do it both ways and make sure they agree with each other. Alrighty. Now, here's a particularly special rule here. When you have brackets that are multiplying with each other, they've got the same terms in there. You've got an a and a 5 in both brackets, and you've got a 1 minus and 1 plus. That fits into the rule that is called the difference between two squareds. So if you've got, here I'll show you a general rule, x plus y multiplied by x minus y, the rule says. That will end up equaling x squared, the first term squared, minus the second term squared. So if we applied it in this case, we can say that there's a shortcut that says this one will equal the first term squared, a squared, minus the second term squared, which is a 5 squared. And a squared is fine, but a minus 5 squared could be turned into a minus 25. That's called the difference of two squareds, and sometimes we use it to factorize this into two brackets there as well. We'll use that when we start to do some factorizing. But yeah, that's the system there. That's called the difference between two squareds, or difference of two squareds, and it works whether you've got the minus bracket first or the plus bracket second, because when we multiply, the order doesn't matter, does it, in that? So a squared minus 25, bit of a shortcut one there. It would save us a fair amount of time if we know that rule, because doing it the long method, what will happen is two middle terms will cancel each other out. You'll get a minus 5a and a plus 5a that would cancel each other out if you did that the long way. And same deal here. Your first term is 5n and your second term is a 2 in each case. And there's a plus and a minus in there. So if we follow that previous rule, our first, when we expand this one, what will happen is we have 5n squared minus our second term squared. Have to be a little careful because 5n squared isn't 5n squared. It's 5n times 5n, which is our 25n squared. Careful with that. Minus 4. That's following that same rule from the last slide there. So when we've got same numbers but a different sign in each bracket there, you can follow this rule. First term squared minus the second term squared. Good shortcut, that one. Alrighty, this is an expansion on steroids. We'll just split that up and we'll multiply d through that bracket, and then we'll separately multiply 3 through that bracket. So we'll have d outside of d squared plus 4d plus 7, and for the second bit plus 3 outside of that big long bracket at the end there. Okay, let's do this carefully. D times d squared is d to the power of 3. D times 4d is 4d squared. D times 7 is 7d. 3 times d squared is 3d squared. 3 times 4d is 12d. 3 times 7 is 21. Now we can't leave it like that because we've got a couple of like terms opportunities to join up here. We don't have any other cubes other than that first d cubed, so we'll write that down. There's nothing to join up with him, but you can see that we've got a plus d squared, and plus 4d squared, sorry, and a plus 3d squared. That can be a plus 7d squared. We've also got a plus 7d and a plus 12d there that can join and make a 19d. And we've got a 21 on its own there. So that's quite a bit there. We split the front bracket up and multiply the d through this bracket. Then we multiply the 3 through that bracket. Then we'll collect like terms wherever is possible. Okay, got another one making us work hard today. If we split that middle term up, e can multiply through that bracket, and then minus 2 can multiply through that bracket. When we multiply minus 2 through that bracket, we'll have to be very careful with our work to make sure we get the right signs in the right spot there. Anyway, e outside of this monstrous bracket to the side. It's not that huge, but working hard here. We'll just write this out, and then we've got a minus 2 for the second bit there that needs to multiply by the same bracket. Alright, let's do some expanding. E times e squared is e to the 3. E times 4e is plus 4e squared. E times 5 is 5e. Here we're going to have to be very careful. Minus 2 times e squared. Minus 2 times a plus 4 is going to be minus 8, and we'd have an e next to it. Minus 2 times plus 5 is minus 10. Let's have a look at the like terms we can write down. E cubed is the only cube bit. We've got 2e squared terms. We've got a 4e squared minus a 2e squared, which would leave us with a plus 2e squared. 4 minus 2 is 2. We have a plus 5e and a minus 8e. We're taking away more than we have there. It's a number line job there. Minus 3e. Minus 10. Boy, made us work hard there. But we only collected the like terms, and like terms have to have the same letter and power. Alright, and that'll do us. Quite a lot of binomial products there, and we went through one of each type, so I'm hoping that helps your studies. Catch you next time, peterblakemaths.com.